We're starting now the trigonometry chapter. I know that for some people, trigonometry is often regarded as a hard topic. I hope that by the end of these lessons, you have a different opinion, if this was your opinion to begin with. And at the very beginning, I want you to pay attention to the things that you need to know from previous years. You need to know, obviously, something that you know for a long time, which is the Pythagoras theorem that regard the relationship between the sides on a rectangle triangle. You also need to know, it's not very often that something like this is used, but it's assumed that you know the sine and the cosine rule, which is valid for any triangle, not only a rectangle triangle. All right. So all these things you are assumed to know. I'm not going to even talk about them. Well, you are in the Math A-Level. You already were tested on these. I'm going to assume you know what they mean, how to apply them, etc. I'm going instead to the very basis of what this chapter is about. Starting with this thing that is called trigonometric identities. There are lots of them. For Math AS, you only need to know 2. In order for you to understand this, let's start by introducing the unitary circle. What is a unitary circle? As the name suggests, this is a circle that has radius 1. Okay, so the radius of this circle is always 1. So let's put a certain angle, a random angle theta over here, okay? And let's look at the triangle that is created if you bring this point of contact with this line with the perimeter of the circle down and to the left. Well, you'll see here this triangle, which is equal to that one, but let's focus on this one over here. Okay, you have here a rectangle triangle, and the size of the hypotenuse is 1. It's a unitary circle, remember, so you know that the size of this is 1. What is the size of x and what is the size of y? Well, you know from previous years that the sine of this angle is determined by the size of the opposite side to it, this over here, divided by the hypotenuse. Now, how big is this? This is as big as that over there, right? The size of this vertical line over here is the value of y over here, right? So by definition, the sine of the angle is the opposite side, which is y, divided by the hypotenuse, which is 1, and basically the sine of the angle is just y, all right? So if you're using the unitary circle, sometimes also called the trigonometric circle, the sine of an angle is measured here on the y-axis. If this angle varies, so will the value of its sine, right? Same thing goes for the cosine. What is a cosine? Is the adjacent, the size of the adjacent side to the angle, divided by the hypotenuse. So in this case, it's x divided by 1 or just x. So where is the cosine measured in a trigonometric, the unitary circle, is measured on the x-axis. As the angle varies, the value of the sine will also change, right? What about the tangent? The tangent, as you know, is the size of the opposite side to the angle divided by the adjacent. So basically, using what we already know, is going to be y divided by x, but y is the sine of the angle and x is the cosine of the angle. So basically, the tangent of this angle is the sine divided by the cosine of that very angle. Where is it measured? Ever wondered why the tangent is called tangent? Well, it is measured on a line that is tangent to the unitary circle on the point where the angle is 0. It's measured over here. So the tangent over here is 0, is going to increase, and it tends, as the angle tends to pi over 2, sorry, I didn't talk about radians yet. As the angle goes to 90 degrees, the value of the tangent tends to infinite. As it tends to minus 90 degrees, it tends to infinite as well, but on the negative side of this line. All right? So this is the very first identity that you need to know. The tangent of the angle equals the sine of the angle divided by the cosine of the angle. The other one comes from the Pythagoras theorem. If you look again at this triangle, you will learn that the hypotenuse squared, or you will know that the hypotenuse square equals the adjacent square plus the opposite square. In other words, 1 squared equals x squared plus y squared, but x is the cosine and y is the sine. So you will know that the sine, the 1 equals cosine square of the angle plus the sine square of the angle, or putting it simpler or in another way, sine square plus cosine square of the angle is 1. Here you have the two identities that you will use to answer a specific category of questions that you will find in exams, which are the identity questions that I usually take as a game. You already know the end result. You just need to use these two tools to step by step go from one place to the other. You'll have examples on the forthcoming questions that you have in this course, so you'll have the opportunity to practice with these. But basically, this is the only thing that you need to know, and you will also have this in the MF19. Not that you are going to use them, because you'll solve so many exercises that this is going to be trivial. But anyway, these are the two formulas that you're going to use. I want you to pay attention also to some characteristics that relate to the sine, the cosine, and the tangent when we are dealing with the unitary circle. Namely, these characteristics over here. Let's go one by one, focusing first on the sine. Okay? If you have the sine of this angle and you add to this angle theta another angle that corresponds to one full circle, so another 360 degrees, you end up in the same place, right? If you now subtract, if you start with the angle theta and now subtract one full circle, 360, you end up in the same place. This explains this equality over here. Sine of the angle plus or minus 360 is the same as the sine of the angle. This is called a periodic property of the sine. All right? Let's look at this one now. You have the sine of minus theta. What would minus theta be in this example? If this is theta, minus theta is this over here, right? What is the sine of this angle? Again, the sine is measured on the y-axis. It is this over here is minus y. So sine of minus theta equals minus the sine of theta. Y times minus 1 is minus y, right? Sine of an angle, and then you add or subtract half of a circle. So let's say that you start here, and then you add half of a circle, 180 degrees. You end up over here, right? If you start over here and you subtract, you end up over here as well. And what is the sine? Is going to be minus y, right? So sine of an angle plus or minus half of a circle is minus sine of that angle. What if you do the other way around? What if you do sine of 180, half a circle, and then you subtract the angle? What is this? 180 degrees, and now you subtract the angle theta. Okay, you end up over here, right? What is the sine? The sine is going to be y, the same as over here, right? Again, 180 minus theta. The sine is the same as the sine of the angle that you started with, right? So sine of 180 minus theta is the sine of theta, and this is the symmetry property. These two, this and this, they are symmetric. They have the same value of the sine. So this is called the symmetry property. Let's now look at the cosine. Again, cosine of an angle plus or minus a full circle, you also end up in the same place. So it's the cosine of the angle that you start with. Again, the periodic property for the cosine function. What if you have cosine of minus theta? Cosine of minus theta is over here, is the same as the cosine of theta. So this is the symmetry property for the cosine. All right, let's look at these two as well. Cosine of an angle plus or minus 180. If you add or subtract 180, now the cosine is going to be measured on this side. It's going to be minus x. So this is minus cosine of theta. Cosine of 180 minus the angle is also measured over here. So it's the same thing. It's also the minus cosine of theta. Moving on to the tangent. If you have an angle and you add a full circle, you will end up in the same place. So the same situation. But I'm going to skip one. I'm going directly over here. But if you add half a circle, you end up over here. So how do you measure the tangent of this angle? You don't have any tangent line over here. The only one that you have is over there. So what do? If you have an angle plus 180, and basically for any angle that goes to the second quadrant and the third quadrant, by the way, you can divide this into quadrants, first, second, third, and fourth. For any angle that lies on the second and the third quadrant, the tangent is measured by moving on the line to this side until it touches that line. So if you have theta plus 180, what is the tangent of this angle? Is measured here as well. So since this is smaller than that, the periodic property for the tangent is this one over here. You don't have to add a full circle. You just have to add half of a circle for you to have the same tangent. The tangent of minus theta is this one over here, minus t, so is minus the tangent of the theta. And tangent of 180 minus theta is measured over here, is also minus t, so it's also minus tangent of theta. Now, should you memorize this? Absolutely not. All right? The idea is that you have this circle inside your head, so to speak. At least that's how I did it when I was a student. I'm going straight over here. I'm going to talk about this later on, but this is part of the things that you can download. But I urge you to build yourself this circle. I'm going to talk in a bit next lesson about these values over here, but this is a unitary circle. This is a trigonometric circle. And if you have this with you all the time, eventually you will know by heart all these relationships just by looking at them. The same way that I explained a little while ago using this tinier one, okay? You can infer all these relationships just by looking at the trigonometric circle. So I'm going to state this again in the next lesson. Use this trigonometric circle that you have here as a guide for you to build your own. I did this when I was a student. I did it actually with a compass. I put all the values there. I carried it with me all the time when I was studying trigonometry. And eventually, sooner than I thought, I had memorized the circle. I wouldn't need it anymore because the circle was already inside of me, and all the questions that related to trigonometry were from that moment onwards so much simpler because all the relationships that regard trigonometry, I had already owned them because I interiorized the trigonometric circle. So my true hint for you, if you want to excel at trigonometry, is by starting to reproducing that trigonometric circle in a construction done by yourself. Not just printing it, but done by yourself. Trust me. Okay? Going back over here. Let me just zoom this in again. Whoa. Wait a second. Until now, I've been talking about these angles using the unit that you learned for a long time. You know that a full circle, has 360 degrees. Have you ever wondered why 360? This number was arbitrary in a sense that it was decided by people a long time ago, millennia ago. Why 360? What is the other number that goes around that 360? If you think a little bit, this is more or less the number of days in a year. So basically they decided to divide the circle, in the same number of unit angles as the number of days in a year, roughly. 360 also has the advantage of being a multiple of 60, and most of the math that was being done back then didn't use the base 10 system that we use right now. They use the base 60 system, and 360 is a multiple of 60. So just by sheer tradition, this was still used and is still used until today. But there is another way to divide angles that depend on the circle itself, not in any external factors such as the number of days in a year. Okay, this relates to what the circle is to begin with. And a circle is a construction that is the same all over the universe, so it doesn't depend on circumstances that happen only here on Earth. So what is this new structure, this new angle, which is, by the way, called the radian? The radian basically is the angle subtended to an arc whose length is the same as the radius. Look at this diagram. Let me zoom in a little bit more. This length over here of this arc over here is the same as the radius. If the radius is 1, this length is 1. If the radius is 2, this length is 2. If the radius is 3, this length is 3, right? Doesn't matter how big the circle is, the angle is always going to be the same. This angle over here is called 1 radian. All right? So 1 radian is the angle subtended to an arc of a circle whose length is equal to the circle's radius. Okay? If the angle is the full circle, how much is that in radians? It's not going to be 360 degrees anymore. We are using a different angle structure. So how much is that? Well, you know that the perimeter of a full circle is 2 pi r. You know this for a long time, right? If you divide this by the radius itself, then you just have 2 pi. So the angle in radians of a full circle is 2 pi radians. Okay? Don't forget here, if you wanted to begin with, this is 1 radian because you are dividing the length, the arc length, by the radius. So r divided by r is 1. Here the arc length is 2 pi r divided by r is just 2 pi. If you have half of a circle, then this perimeter of half of a circle is just pi r, right? Not 2 pi r, but just pi r. If you divide by r, then the angle is just pi radians. You can continue doing this and get all the most common angles in radians. All right, you can do it yourself, but you have that simplified or summarized in this table. You have here the angles in degrees, the most famous, the most used angles from 0 to 360. Okay, so for the first quadrant, you have the 0, 0, 30 degrees, 45 degrees, 60 degrees, 90 degrees, and then multiples of this throughout the circle until a complete cycle, right? This is the corresponding value in radians, all right? So 30 degrees is what? Is pi over 6. Think a little bit of this. What is pi? Pi is 180 degrees. 180 degrees divided by 6 is 30, right? So 30 degrees is pi divided by 6, pi over 6. 45 degrees is what? Is 180 divided by 4, right? So in radians, you just write it pi over 4. How much is 60 degrees? Is 180 divided by 3, so pi over 3, and so forth, all right? So you have here all the values of the angles in radians, the corresponding angles in radians. And then you need to know this, and this seems too complicated, right? You need to know by heart these values. You need to know. Eventually you will know, all right? Actually, you don't need to know, but you will because of the amount of exercises that you're going to solve, and the fact that although it seems a lot of stuff to memorize, eventually you just have these values to memorize. You have repetition of values over here. Okay, you have here the values of the sine of pi over 6 is 1/2, the sine of 7 pi over 6 is minus 1/2, etc. If you look at these values, I use here a color scheme to point out repetitions, okay? And for the sine and the cosine, you have the same values. Positive or negative, square root of 3 over 2, square root of 2 over 2, 1/2, 1, and 0. For any of these, you have the positive and the negative version. For the tangent, you have square root of 3, square root of 3 over t over 3, 1 and 0. Again, positive and negative versions. How are you going to memorize this? Again, with a trigonometric circle. I'm looking at the screen to see if you can see this. You can download this anyway, and you'll have access to it. It's kind of tiny, all right? So here you have all the different angles. So 30 degrees or pi over 6, 45 degrees or pi over 4, 60 degrees or pi over 3, 90 degrees or pi over 2, and all of that. Here on this axis, you have the corresponding values for the sines, right? So for example, pi over 3, the sine is square root of 3 over 2, is also the same for this angle over here, all right? Over here is minus square root of 3 over 2. Let's look at the cosine. This is 1/2, which corresponds to the cosine of pi over 3. It's also the cosine of this angle over here, all right? You have here the angles both in degrees and in radians, all right? Here on the vertical tangent line, you have the values for the, why isn't this moving up? Okay, for the tangent, the square root of 3 would be too far up, and the minus square root of 3 too far down on this tangent, so I pointed like up and down. It will be the continuation of this line until it would meet the tangent there and there, okay? But again, I'm going to stress this again. Use this as a guide, use a compass, get a white sheet of paper, draw a circle, divide this correctly. Don't forget this is 30 degrees, then just draw a line like this. This is 45 degrees, draw a line like this. This is 60 degrees, draw a line like this. Don't forget to begin by doing the vertical and the horizontal axis, and continue doing so. Then do these lines. Be careful. Make a circle that you like looking at, because you are going to look at it a lot. And trust me, this is going to speed up the process of you understanding questions regarding trigonometry. You have most of the information, the relationships, the structure of how trigonometry works in a very visual way, okay? So the next step that I want you to do, even before starting doing exercises, is using this guide to build your own trigonometric circle.